I am Partha Sarathi. I am presenting our MobileHCI 2020 paper, Disaster Strike, Internet Blackout, What's the Fate of Crisis Mapping. The authors are myself, Partha Sarathi, Ankan, Ghosh, Sujoy, Saha and Subrata Nandi from National Institute of Technology, Durgapur, and Bishakh, Chandra, Ghosh and Sandip Chakraborty from Indian Institute of Technology, Kharagpur, India. We present here in this paper a smartphone-based offline crisis mapping platform called Soteria. By offline, we mean it works without the presence of internet. Basically, a crisis mapping system encodes disaster-specific GIS information on a map of the affected area. By disaster-specific information, we mean the drop zones, helipads, roadblocks, shelter points, etc. And crisis mapping systems, online crisis mapping systems collect this data from online sources like social media and news channels. But all of them use internet. But we know internet often breaks down after disaster. So in that case, crisis mapping becomes difficult in the affected area. So here comes the internet-less systems like Soteria. We have conducted a thorough motivation survey in the field as well as in online mode. From field, we have collected altogether 155 feedbacks, 85 from our NGO members and 70 are government officials. And in online mode, we have collected 483 feedbacks, and by analyzing, we found out that the general opinion is there is a huge gap between crisis mapping infrastructure and the last mile agents like the victims and local volunteers. So basically, what we observed that there is a general demand for a system for last mile data collection, and such systems should use off-the-shelf devices like smartphones. And such a system should provide seamless experience to the users and should be non-obtrusive in the sense that it should not hamper normal functionalities of the user. In addition, such a system should have on-device data validation and GIS data summarization and must be energy efficient to be used in a disaster situation. Soteria kind of have features that meet some of the at least majority of such requirements. It uses smartphones and some optional, precisely quote unquote optional customized devices that we call information drop boxes and data mule. It actually works in a delay tolerant ad hoc networking mode, and the data propagates through it in a store carry forward manner. It has a self-contained Android application through which users can share text, multimedia, and GIS messages. And in sharing those messages, users require minimal user intervention, so it provides a kind of seamless user experience. And in addition, it provides with an automated on-the-device GIS summarization, which I'll explain shortly. Now, here in this slide, we show the component devices used in Soteria. The Android application, information Dropbox, which is a custom-built device to be placed at strategic locations like shelter points, etc., and data mule that actually are nothing but vehicles mounted with information drop boxes, and the vehicles are like ambulances, police cars, etc. The data exchange takes place here when any pair of such devices come in close contact, like here as I shown. Whenever any two devices come in contact, data exchange takes place, and in this way data moves from one place to another. This is the Soteria application architecture. It is a two-tiered architecture broadly. The back end is the management plane and front end is the user interface plane. The front end is responsible for GIS as well as multimedia data collection, data processing and storage, and generation of crisis map from those data. And the back end is responsible for the opportunistic networking using the device component devices, and the using the component devices and data sharing among them. And basically the bottommost layer, P2P Connect, it actually uses Wi-Fi direct for data transfer, and to save energy it uses acoustic based signaling for neighbor discovery. P2P Sync, immediately on top of that, it actually responsible for sharing data using P2P Connect, and it employs a kind of best effort data sharing because the connectivity here are short-lived and intermittent. As far as the implementation is concerned, the GIS systems are implemented using KML format, that means keyhole markup language. For GIS visualization, we use OSM Droid Android tool, and we have also provided a kind of end-to-end encryption of the messages in a PGP manner. For merging GIS object is very crucial. We merge a pair of GIS objects when they are spatially co-located, when they have near identical contextual metadata, and they have near identical structures or geometrical shapes. So here, by spatially co-location means they share a common map tile of the same zoom level. They have identical metadata that can be compared using TF-IDF scope, and geometrical shape that can be measured using Hausdorff distance measure. Now, if all these conditions are satisfied, then the GIS will be merged like this in the figure shown side by side. Now, for performance measure, we have actually plotted the number of GIS objects counted at each interaction, and we see the number of GIS objects reduces if we use GIS summarization, and that reduction is significant. That is quite promising. We also measured power dissipation by the node, and we see the acoustic based neighbor discovery improves the power profile of the system, and that is also good for our application scenario. We have also conducted user survey with the device. We have collected online feedback as well as in-field feedback by participating 3 more disaster mock drills. We have a significant number of feedbacks both online and offline. We have plotted the feedback against here against some important features like simplicity of the system, usefulness of the system, usefulness of the summarization module, and the overall system rating. And we find around 50 to 80% feedbacks are positive, and even higher feedback in drills. As a conclusion, we can say that such a system is readily deployable after disaster because it uses readily available devices as well off-the-shelf devices. The design is energy aware, and we have found out all this by rigorous performance testing in the field as well as lab, and we have conducted thorough user survey. As a future scope, we can say that we have considered that internet connectivity is absent completely, but it may not be the case in reality. So we can couple Soteria with online crisis mapping system, as well as we can integrate it with online social and news media as data sources. And since we can also try sophisticated GIS summarization, on-device GIS summarization techniques, which might improve the performance. And that is more or less all. We conclude here. Thank you.